This is Geometry Chapter 6, Section 2, in which we will be studying parallelograms. Before we can study them, we need to know what they are. So a parallelogram, I'll bet you could have filled that blank in without even me clicking that, is a special type of quadrilateral. It means it's got four sides. And here's the deal. Both sets of opposite sides are parallel. That's what makes it a parallelogram. It has two sets of parallel sides. And the symbol for a parallelogram looks like this. It's basically a rectangle with the wind blowing. So it's kind of blown it tilted. Okay. So what the definition of a parallelogram tells us, if I'm looking at this one, ABCD, definition tells me that AB is parallel to CD, which I have marked with one set of arrowheads. And also AD is parallel to BC, which I have marked with two sets of arrowheads to show that those two are parallel to each other, but not to the first two. Okay. Now, the fact is that with parallelograms, you get a lot of interesting properties that work just for parallelograms. And we're going to look at some of those, and they give them all to us in theorem form. The first idea is if you have a parallelogram, then opposite sides are congruent. So referring back to the one that you have on page 1 of your slide here on your note sheet, AB would be equal to CD, would be congruent to it, and AD would be congruent to BC. Same thing holds true for opposite angles. Angle A is congruent to angle C. Angle B is congruent to angle D. If you're dealing with a parallelogram, then it's also true that consecutive angles are supplementary. I didn't put a thing here for you because you'd have to list 4 things. But the idea is A plus B equals 180. B plus C equals 180. C plus D equals 180. And D plus A equals 180. Again, I'm looking back at the picture on the first slide. And then here's a nice property. If a parallelogram has one right angle, then that's going to make all 4 of them right angles. Now, I'll let you ponder that, and if you need help understanding why, you can ask in class. So let's consider this beautiful parallelogram. And our job is first to find the length of CD. Well, CD will be the same as AB, so it's 4.1 feet. Find BC, well, that's kind of silly. If it tells me it's 1 foot, then it's 1 foot. Kind of a trick question, I guess. Angle C is the same as angle A, so it's 64. And angle D, since it says consecutive angles are supplementary, 180 minus that 64 gives me 116. Just using the properties that they gave us. Now there are some other properties of parallelograms that are really nice, and they deal with the diagonals. Okay. If I draw in the 2 diagonals, and I'm dealing with a parallelogram, then the diagonals bisect each other. That is, they cut each other in half. That is, they intersect at a midpoint. So line AC bisects line BD. It makes this part equal to this part. And similarly, BD bisects AC. Okay. if you had to prove that, hint, 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 you might think about going for congruent triangles. Like with an angle side angle type argument. Because you got parallel lines. Just if you ever had to prove that. I don't know if it's going to come up or not. And speaking of congruent triangles, if you have a parallelogram, then the diagonal splits you into two congruent triangles. Again, I would consider an angle side angle kind of argument because you have parallel lines and you have a transversal. But that's just me. As always, your mileage may vary. So let's do a couple of more problems. And then we'll get to a fun proof, and then we'll see where we end up. They want us to find the value of each of the variables here. Well, we know these two are equal to each other. Oop, wrong place. These two are equal to each other because they're the same side. They're opposite sides of each other. So 5y is equal to y plus 8. Subtract the y over and divide, and we get what y is. We know the two angles are supplementary. I already let the cat out of the bag there. The two angles are supplementary because they're consecutive angles. So collecting up, moving a little algebra around, and we get what x is, 31. And then finally for z, since these are the two diagonals, they bisect each other. So that means those two pieces are equal. Well, moving the z over and moving the 4 over, and then dividing, we get what z is, 4.5. Okay. So not too bad. Just have to recognize who's equal to each other and who are supplementary with each other. Now suppose they throw something like this at us. They want us to find the coordinates for the intersection of the diagonals of a parallelogram RSTU given these vertices. Well, if they want us to find the intersection of the diagonals, what we're really interested in is finding the midpoint of one of the diagonals. We can either use RT or we can use SU. I chose RT just because I did. No apparent reason. And all we have to do is find the midpoint. Negative 8 plus 6 divided by 2, and negative 2 plus 7 divided by 2. Negative 8 plus 6 is negative 2, divided by 2 is negative 1. Negative 2 plus 7 is 5, divided by 2 is 2.5. If you got negative 5 for this, when you punched it into your calculator, because I know you're following along and making sure you can get to the right numbers. If you got negative 5, you need to put parentheses around your negative 8 plus 6 when you put it into your calculator. It's kind of a heads-up checkpoint. And if you didn't already try to find that out, grab your calculator and do that so that you can make sure you can do this correctly. And as promised, as you saw on your note sheet, there is a proof coming your way. But don't sweat, it's a nice easy one. We're given two parallelograms. And we want to end up proving that this segment HJ is congruent to this segment ML. Well, knowing we have a parallelogram here, HJKP, tells me that HJ is congruent to KP. Knowing the other one is a parallelogram tells me that PK is congruent to ML. Those are opposite sides, So it would be theorem 6.3. Unfortunately, it doesn't have a nice name, so I'm just going to have to stick with the number for it. If you wanted to write opposite sides of a parallelogram or congruent, you could do that. Well, now look at what we've said. They're both equal to the same segment KP, so that means they're equal to each other. That's the transitive property, or if you wanted to say substitution, that would work as well. So a nice, easy proof to ease you back into thinking about those. So parallelograms, two sets of opposite sides are parallel, and you have all kinds of neat properties that we talked about theorems for. If you have questions along the way, as always, I hope you jotted those down. Bring them in and ask them in class, and we will see you in class.